All right. This is the Trig Lecture for 9.2 and 9.3. There will be a corresponding worksheet, worksheet 9.2 and worksheet 9.3 in Trig. Our objective today, the student will use inverse trig functions. I'm going to define those for you. Inverse trig functions to find the measure of a given angle in a right triangle. So we're going to be messing with right triangles some more. And we're not going to know the measure of a given angle, and we're going to find it using inverse trig functions. So let's just jump right into one, and in the course of doing that, I'll define what an inverse trig function is. On the worksheet, you might have a problem that looks something like this. It'll say, find the measure of theta, round to the nearest tenth. Okay, so I look at this, and I see I've got a right triangle. That's very important. That tells me I can use my trig functions. And I've identified theta. The A, B, and C might be there, they may not be, but this is the angle I'm looking at. Find the measure of angle theta. And I want to know the measure of this. Well, I know that this side right here is 3, this side right here is 5, and I don't know this side, but I don't really need this side. I'm going to show you a thought bubble. You don't have to actually write this, but here's what's going on in my head. I'm thinking, well, the cosine of theta is 3 over 5. If I try to use the sine, I go something that's unknown over 5, so I wouldn't try that. If I try to use the cosine from here, I say, well, the cosine of theta is 3 over 5. So I'm thinking, well, I can find the cosine of theta if I wanted to. The cosine of theta would be 3 over 5. This is just a little thought bubble. That's what I'm thinking. What this tells me is that if I know that the cosine of theta is 3 over 5, then I can take what's called the inverse of the cosine of 3 over 5, and I'll know what theta is. And here's what that looks like. The inverse cosine, oops. I'm having trouble writing. Having a small stroke or something. There we go. The inverse cosine of 3 over 5 will be equal to the measure of angle theta. So this little thing that looks like an exponent that's a -1 right here, this tells my reader that I'm going to take the inverse cosine of a known ratio that's the cosine of an angle. The cosine of theta is 3/5, so the inverse cosine of 3/5 will give me the measure of this angle. And so that would be theta. And now I just need to know how to plug this into my calculator. If I can get this into my calculator, I'll know the measure of angle theta. So I'm going to try to put it in my calculator. And here's what I would do. Here's the type of calculator I'm using. This is the type of calculator, I'm pretty sure you guys can check it out here at the school. You can check one out. We should have enough for everybody, I hope. This is called a TI-30XS. I'm sure you've all seen them in geometry and in Algebra 1. And so I'm going to use this calculator to take the inverse cosine of 3/5, and it's going to tell me what the measure of this angle is. And if you look up here in my instructions, it says round to the nearest tenth. That's the first decimal place. So what I'm going to do is I'm going to turn my calculator on and hit clear, because there's probably some garbage in there. And then I'm going to hit the second function, that little thing right there, the little green button, hit second. And then I'm going to hit the cosine button, which is right there. And if you look up above it, it has this symbol right here, the inverse cosine. It looks like cosine with a little -1 floating up above it. That's the inverse cosine. So I'm going to hit that, and it pops up on my screen, the inverse cosine in an open parenthesis. What I want to do is put the fraction in there, 3/5. You can do it using your fraction tool, or you can just go, I usually just go 3 divided by 5, because that's what a fraction means, 3 divided by 5. But if you want to use the fraction button, that's just fine. Make sure you close this parenthesis and then hit enter. 53.13, so theta, I can say therefore, that's those 3 dots in math, that means therefore, the word therefore. Therefore, theta is about, that squiggly equal sign, is about 53 0.13010, and it goes on forever and it'll never repeat. But I'm asked to round it to the nearest tenth, so I'm going to call it theta is approximately equal to 51.1 degrees. I rounded it to the tenths place, that's the first place after the decimal. Now I look to the 100th place. If this is a 5 or bigger, I would call that a 2. If it's a 4 or less, I'm going to leave it a 1. And there's our answer. In this case, providing I haven't made any mistakes, theta would be 51.1 degrees approximately, rounded to the nearest tenth. Okay? Let's take a look at the next example. I've got another right triangle. I'm asked to find the measure of angle theta. So B, C, A don't come into play. I'm just looking for theta because that's what it asked me to do in my instructions. And so I'm looking up here and I'm analyzing this a little bit. I say, well, if I say the sine of theta in my head, do I have the two sides that I could use the sine on? And I look up here and I say the sine is opposite over hypotenuse, and I can use that. If I was thinking cosine, I would say, well, unknown over the hypotenuse, so I wouldn't use cosine. If I was thinking tangent, I would say, well, that's opposite over adjacent, and that's an unknown also. So I want to use the sine because those are the two sides I know with respect to this angle. So I'm going to say, I'm thinking again. This is just a little thought bubble. You don't have to write this, but this is what's going on in my head. I know that the sine in this case of theta is equal to 9 over 10. Therefore, I can say that theta is equal to the inverse sine of 9 over 10. And all I got to do is figure out how to get the inverse sine of 9 over 10 into my calculator, and that will give me an approximation for theta that I can then round to the nearest tenth because that's what my instructions ask me to do. So again, I take my little TI-30XS and I clear it. And I hit second function because I'm not going to be using the sine, cosine, or tangent. I'm going to be using this inverse sine, inverse cosine, or inverse tangent. That's what the second function will do. So I hit second function. I'm using inverse sine, so I hit the sine button. And then my screen reads inverse sine in an open parenthesis, so I just put this fraction in there, 9 divided by 10. 9 over 10. Then I close my parentheses. You have to close those parentheses, and I hit enter. And that tells me it's about 64.2 degrees, approximately. That's rounding it to the nearest tenth, which is what we were asked to do. So if this is 9 and this is 10, then this would be about 64.2 degrees. And we could round this, to whatever precision we want. And we were asked specifically to round it to the 10th, so that's what we do. And then you would look among your choices. These are going to be multiple choice. You look among your choices, see which one says 64.2 degrees, and pick it. And here's one more example. Again, I'm asked to find the measure of angle theta, so I look at this, and I say, well, here's my theta. I can ignore my A, B, and C. And I'm given two sides, and so I think, well, if I take the sine of theta, that would be opposite over hypotenuse. I don't know what that side is, so I don't want to take the sine. I don't want to use the sine. If I use cosine, that would be adjacent over hypotenuse. Remember, the longest side of a right triangle is the hypotenuse. So 24 over an unknown, again, I don't want that. I want to have two sides that I know, and the right trig function that involves those two sides. So I'm looking at this and I said, well, how about the tangent of theta? I look at the tangent, and that's opposite over adjacent. I have these two sides, so I'm thinking to myself, well, if the tangent of theta is 15 over 24, and this is just a thought bubble, you don't have to write this. You can write it if you want to, but it's not necessary. I can therefore say theta is the inverse tangent of 15 over 24. Now I've got to figure out a way to put that in my calculator. So again, I go to my calculator, a little TI-30XS, and I clear it to get that stuff out of it, and I hit the second function, then I hit the tangent button, and now my display reads inverse tangent with an open parenthesis, and I just have to put this 15/24 in there. That's 15 over 24. 15 divided by 24. However you want to do it is fine, as long as you get that fraction in there. Close your parentheses, it's very important, and hit enter. And this is about 32 degrees. I'm going to say 32.0 just to tell my reader that I rounded this to the nearest tenth. It'll round to the nearest tenth. It goes 32.005831. It'll never repeat. It'll keep on going forever, but rounded to the nearest tenth. This angle is very close. If this is 24 and this is 15, this would be very close to 32 degrees. Now, none of these triangles that I've drawn up here are actually to scale, but they're close enough. So that's what we're doing. We're finding the measure of an angle given some information about a right triangle. So let's run through this again real quickly, and then I will let you get started. This is lecture 9293. There will be 2 worksheets that go with it. The student will use inverse trig functions to find the measure of a given angle in a right triangle. So we're given a right triangle. Here's our given angle. If I went sine, that would be blank over 5, so I don't want to use sine. If I went from here, I evaluated cosine, that would be 3 over 5. So I'm thinking, okay, the cosine of theta is 3 over 5. Therefore, the inverse cosine of 3 over 5 is theta. So I take the inverse cosine of 3 over 5 using my calculator, and I find that it's about 51.1 degrees. And I used an approximation symbol that's just a little squiggly equal sign. There are 2 accepted approximation symbols in math that you'll see all the time. There's a squiggly equal sign, that means approximately, or a regular equal sign with a single dot above it. Both of these mean approximately. Okay, now I'm going on to number 2, and we looked at this and we just analyzed it for a second. I said, well, if I say the sine, here's my angle, this is my given angle. If I say the sine of theta, I'm going to go opposite over hypotenuse, and hey, I've got everything I need. So I say, I'm thinking this. You don't have to write it, but you can. I'm thinking this. And I say, well, if the sine of theta is 9 over 10, then theta is the inverse sine of 9 over 10. That's what this little symbol means right here, inverse sine. Then I just have to plug this into my calculator. So I go to my calculator, hit second, sine, put this in, and it tells me that theta is approximately 64.2 degrees. That little squiggly equal sign is an approximation symbol. And the last one, we looked at this and we said, well, if I use sine, that's opposite over hypotenuse, can't do that. Cosine is adjacent over hypotenuse. I still don't know the hypotenuse, so I can't use cosine. But tangent is opposite over adjacent. So I think, well, if the tangent of theta is 15 over 24, then theta is the inverse tangent of 15 over 24. If I can get this into my calculator, it will tell me the measure of angle theta. So we use our calculator, evaluate the inverse tangent of 15 over 24, and that gives us theta rounded to the nearest tenth, because that's what we were asked to do, is approximately 32.0 degrees. That's what we'll be doing on the worksheets, and I think you won't have too much problem with it, but if you do, I will try to answer your questions to the best of my ability.